Hello everyone, let's start solving today's daily challenge question. So the question is successful pairs of spells and potions. You are given two positive integers arrays, spells and potions of length n and m, where spells of I represent the strength of the ith spell, potions of I represent the strength of jth potion. You are also given an integer success. A spell and a potion pair is considered successful if the product of their strength is at least success. That means what? Spells of I is strength of the spell into potions of J, strength of J potion should be greater than or equal to success. That is what given in the question. So this is given. Now let's see what is written. Okay. You are given an integer success. It means the successful if the product of their strength is at least success. Return an integer array pairs of length n, where pairs of I is the number of potions that will form a successful pair with the ith spell. Okay, so we have to return what? We have to return an array which will be size of what? Size of is equal to spells dot length, because we have to return the number of pairs which are successful from spells. Okay, so let's find out for this. Now, what we will do is here consider for 5. 5 can be paired with what? Into 1 if we do, which is 5. Is it greater? What is our success? Success is 7. Is it greater than or equal to 7? No. So this can't be a pair. 5 into 2 is 10. Is greater than 7? Yes, this can be a successful pair. 5 into 3, that means this. Yes, this can be our pairs. 5 into 3 is 15, which is greater than or 7. Yes, so this can be a successful pair. 5 into 4 is 20. 20 is greater than 7. Yes. Again, 5 into 5 is 25, which is also greater than 7. So now we have 4 pairs for this spells. So my answer first will be 4. Now again with 1, we have to check everything. With 1, how many we'll get? Here if we see in this example, for the first, if we multiply 1 into 1, 1 is greater than 7? No. 2 is greater than 7? No. 3 is greater than 7. If we multiply 4, 5? No. So 0 pairs. So here we will add 0. Now next is 3. 3 into 1, 3. Which is not greater than 7. 3 into 2 is 6. 6 is greater than 7? No. 3 into 3 is 9. 9 is greater than 7? Yes. 4 into 3 is 12. 12 is greater than 7? Yes. 5 into 3, 15 is greater than 7? Yes. So total 3 pairs we got. So my answer will be 403. If you see here, 403 is written. Now this is what the question is all about. But this will be a brute force approach. What will be a brute force approach? Brute force approach is basically you will be doing n cross m. So for n number of spells and n m number of potions, we'll multiply each one with this and find the you will calculate the multiplication and find the pair. Okay, and this is way you will be adding each and including in the answer. But this will be a brute force n into m. Okay, if we see the second example, let's see again the second example. 3 1 2 is there. 3 into 8, 3 into 5, 3 into 8, 1 into 8, 1 into 5, 1 into 8. So 2, so like that you can find out using n cross m. But as if we see in our example, we have the constant till 10 to the raised to 5. Then we cannot use the solution which is of n cross m. If you even solve this, you will get what? TLE. You will get TLE. Yeah. Now, how we will solve this question is, see, what we need to find this. This is our main condition. So consider if I got a portion, okay, if I got a pair, I got a pair, which satisfies this condition. That means my spells, let's say I'll consider S into my P is greater than my success. Okay. I got this pair. That means for this spell, if there are portions in my portion array, if there are elements which are greater than this P, that means this will be successful always. Okay, so I'll get the pair. So I need to find the minimum element for which I'll get this pair, and so that I can say that after this how many elements are maximum after this can be my answer. That means, for example, if see, this is a sorted array. Okay, if I multiply my 5 with 2, I got 10, which is a pair. Okay, that means after this, if I have all the elements greater than this 2, I can say without multiplying, I can say that this can be my successful pair. Yes, so how many are there? Total 4 are there. So my answer for 5 will be 4. For 1, I don't have anything, so anyway I'll have to uh, calculate this. For 3, okay, 3 into 2 is 6. 6 is greater than 7, no. 3 into 3 is 9. 9 is greater than 7. Okay, yes, so this is my least element. Now after that all are greater elements, so I can say this is my, basically my answer will be portions dot length minus my index. Okay, this will be my answer for that, this index. Okay, but instead of going linearly, what we will do, we are going to use the binary search. So what we will do, let's go into the next page. What was our condition is, what we got, S into P should be greater than success. This is one condition. If I have least P, then after that whatever will be the element, that will be also form a pair with this spell. So what will be my answer for the current spell? Portion dot length minus that index at which we got this P. Okay, this will be my answer. Now we are going to use binary search. How is, let's say this is our array. Okay, and we are going to sort it. 2, 3, 4, 5, 6, 7, 8, let's say. Now my number is 6 and my success is 19. Okay, let's say 18, or we can consider it as 16 as well. Okay, okay. Now I want to find a pair where 6 into some p should be greater than 16. That means I want to find a p which satisfies this condition, but p is the least number. Okay, so what we can do is we can go into the middle. We are going to use the binary search. Now 4 into p is 24. 24 is greater than 16. That means this can be my answer. That means this can be my answer. I am not saying about that answer. I am saying about this index. This can be my index. Else we can find more here. That means this can be my least element. After this, all elements are larger than this, but we can find more here. So what I will do is, instead of going further, we know all the elements are greater. This will satisfy. We can get the successful pair. But instead of that, we will go here. Okay. Now what we will do is we will find the mid. As it is a even, this will we will get a mid. Okay. Now after this, we'll get this mid. Now 6 into 2 is 12. 12 is less than 16, not greater than. So we don't want this. Now what we'll do? No. This will not form a pair, so we will move forward. Okay. Now again we will find the mid. We will get this. Okay, in this case 6 into 3 is 18, and 18 is greater than 16, so this can be our possible index. Again this will be my index, so I will update my index to this. Now I will, of course, in binary search we follow what, this approach, high and low. So in this case there is only one element which we got where high and low are same. Okay, then we will stop. What will be our condition? Low less than or equal to I. Then after this we will stop this condition. Then what will be my answer? My answer will be portion dot length is total length is 7. 7 minus the index is 0 1 2. 2, that means I have how many? 5 elements. Okay, that means 3 4 5 6 7 and 8. Oh wait, my total length is how many? 1 2 3 4 5 6 7 8. My total length is 8, not 7. So I got my answer 1 2 3 4 5 6. So these are the elements which can form a successful pair with this. So in this way we will be calculating. So we need to write what? We need to write one binary search function which will return us this index. And yes, this there is a possibility that in this previous example if we see we didn't get anything, so my index can be initial. So instead of 0 we will start our index with -1. Okay, then if we don't get anything, my index will be -1. If it is -1, will not do anything, it will be 0 answer, else we will update it. Yes, this is how we can solve this question. Now let's start coding. Okay, yeah. Now what we will do is we are going to write. Okay, now let's take int answer. First we will be sorting this arrays dot sort spells, not spells. We are going to sort the portion. And here what we'll do for int I is equal to 0, I less than spells dot length I plus plus. And here we need answer. Answer will be size of what? Our spells dot length. Now here what we'll do is we need what? Int index. I want index. Let's say I'll use find, where we need to pass the portion on which we have to what? Run the binary search and the current spell and the success. Yes. So for each it will give us one index. If my index should not be equal to -1. If this is there, then what we'll do? Then my answer of I will be what? Portion dot length minus I. And at the end we will return our answer. Yes. And again here we will write one method, this find public, which will return int find, where it will accept int portion and it will accept the strength of spell and it will accept the success. It should be long. Now here what we are going to do is we need a low which will be initially 0. We need a high which will be initially portions dot length -1. And while my low is less than or equal to high, what are going to do? First we'll find the mid. How we can find the mid? Low plus high minus low by 2 will be my mid. If what? If my what? Portions of mid into my strength is greater than or equal to success. As our success is long, what we'll do? We will cast this into long and we will find this. And here if this is the case, what we'll do is my possible index will be this. is mid, and I will do my high, I'll write my high as mid minus 1. We need to find on the left side, as I mentioned here, on the left side to get the answer. Else, if we don't get this, we will move on the right side. That is, my low will be mid plus 1. So we didn't get anything, that means it is less. And at the end, we will return our index, where we haven't declared index right here. Int my index will be minus 1 initially. Yes, now let's run this. Yeah, okay, we are getting the wrong answer. Let's check why we are getting this. Um, yeah, let's see what is the issue. Portion start length. This is correct, which now we have passed here. Here we first found the mid, and then we multiplied this, and if my high is mid minus 1, low is mid plus 1, index, let's say for 5, why we are getting, we are getting, first sorted, right? Did the sorting, I think. Let's check. Yes, we first sorted the portions, then I have this 5 spells dot length. We will find the, with I will find the success. This is, yes. So here we need to subtract index, not I. Now let's run. Yes, you can see accepted. Let's submit this. Yeah, you can see the solution is accepted. So in this way, we can solve this question using the binary search method. Here if you see, we have the answer will update with minus index. And yeah, thank you so much for watching this video. If you feel this video is helpful to you, please like this video, subscribe my channel, stay updated.